Hello, welcome to this lesson of our study of differential equations. Okay, so we have started solving questions on first order differential equations, and in our first way of solving first order differential equation, we started with a first order differential equation that can be converted, or that can be separated into only functions of x and only functions of y. That is what we just did before this video. But there's another way of solving a first order differential equation, but then we have to make sure that first order differential equation is homogeneous before we can apply that method. Okay, that is a method of substitution. When you see that a first order ODE is homogeneous, then you substitute something to turn it into a separable one. Okay, so the idea in all differential equations is to turn them into separable ones so that you can solve them. Okay, so first of all, you are supposed to know when to say that a differential equation, or a first order differential equation is homogeneous. Okay, but before that, let's start with the homogeneous function. Okay, so if you have not subscribed to my channel, like I always say, kindly subscribe to support the channel. Okay, so homogeneous function. Now a function f of xy, here would deal with f of xy. The function could be f of x, but since idea here is differential equation, that is a function y which is a function of only one variable. We'll talk about a function of two variables here, y and the x. Okay, so a function f of xy is homogeneous if f of lambda x lambda y. Okay, so you know your f of xy somewhere, then when you substitute x and y to be lambda x lambda y, you get back this expression that you get lambda to some power times your same f of xy. And then here your n is the degree of homogeneity. Okay, so I will show you an example so that you understand this. Then you go to when to show that a first order ODE is homogeneous. Okay, to show that the following functions are homogeneous and state their degree of homogeneity. So first of all, we have this f of xy equals x to the power 4 minus s cubed y, and we have f of xy equals y squared over s squared. Okay, so when do we say that these, or how do you show that these are homogeneous? So with the first question, you have f of xy being equal to x to the power 4 minus s cubed y, and we are saying that for this to be homogeneous, if you substitute some lambda x and lambda y by x and y, we should get some lambda to the power in multiplying f of, so we're saying that f of lambda x lambda y should be equal to lambda to the power and multiplying our same f of xy. Okay, so if this is true and we're able to get a number n for the lambda, then our function is homogeneous. So first of all, let's find f of lambda x lambda y. Okay, and that will be equal to lambda x, wherever you see s, you put lambda s there, to the power 4 minus lambda x to the power 3, then y is what? Lambda y. Okay, so when I raise the whole of this to the power 4, I have lambda to the power 4 x to the power 4 minus lambda cubed s cubed, then times lambda y. Okay, but you see lambda can multiply lambda here, and I'll get lambda to the power 4 x to the power 4 minus lambda to the power 4 s cubed y. But lambda to the power 4 is common in both, so we'll get something like lambda to the power 4 x to the power 4 minus s cubed y. But what is x cubed y? Sorry, x to the power 4 minus s cubed y is the same f of xy given. Okay, so this is equal to lambda to the power 4, then f of xy. Okay, so we've been able to express f of lambda x lambda y as some lambda to the power something multiplying f of xy, so meaning that this is a homogeneous function and that our degree n is equal to what? 4. Is of degree what? 4. Okay, I hope you understood this. Now the second one was f of xy being equal to is it y squared over s squared? Yes, y squared over s squared. So y squared over s squared. So here what you do is just simply like we did, find f of lambda x lambda y. Okay, and that will be equal to Wherever you see y, you put lambda y there. Wherever you see x, you put lambda x there. Okay? And then this will be equal to lambda squared y squared over lambda squared s squared. Okay? Then lambda squared can cancel lambda squared, so we'll get something like y squared over s squared. But realize that this is the same as lambda to the power 0 y squared over s squared. Okay? I hope you get this. And this is equal to lambda to the power 0 then f of xy, because our f of xy is y squared over s squared. So here this is also a homogeneous function with our degree n being equal to 0. Okay? And this is perfect. This is true. So in other words, in first order differential equation, if you have your function, okay, depending on the ratio, so if you have, let's say, f of xy, this in this context it was y over x all squared. I can write y squared over s squared as this. Okay, so if you have your function depending on this ratio, then it means that the function is also homogeneous. Okay, that is also another term you can use. Okay, but if you can go through the process and show that the degree is 0, that one too is perfect. Okay, all right, so that is it for showing how a function is homogeneous. Now let's go to showing how a differential equation is homogeneous. Now the first thing is a first order differential equation of the differential form. So this is a differential form. If you can write, or if you can split your differential equation into some m of xy times the x plus some n of xy times the y equals 0, then this is homogeneous if the functions m of xy and n of xy are both homogeneous of the same degree. Okay, they are both homogeneous functions with the same degree. So what do I mean? When I have a differential equation written in this form, okay, in this format, then I have to pick my m of xy, look if it is, or go through it if it is homogeneous, okay, and then come and take my n of xy, go through it if it also a homogeneous function. If they are both homogeneous and their degree of homogeneity are the same, then it means that our differential equation, or our first order differential equation, is homogeneous. Then we can use the method I will show you in our next discussion to solve it. Okay, so the second point is if the differential equation in the standard form, so this is the standard form of writing the differential equation, the first order. Okay, if the y ds, that is the same as y prime, is equal to f of xy, sorry, if you can write it like this, and if this f of xy or this dy ds is a function of, or depends on the ratio y over x or x over y, then it is said to be homogeneous, or the first order differential equation is said to be homogeneous. So the first thing is, we have two ways of showing that the first order differential equation is homogeneous. One, you have to make sure that if it is written in the differential form, that is the m of xy and the n of xy, they are both supposed to be homogeneous function with the same degree. Or when it is written in the standard form, the differential equation, or the y prime, depends on the ratio y over x or x over y. So these are the 2 points you use to state that a differential equation, the first order, is homogeneous. So let's pick examples. So example, you are supposed to show that this is homogeneous, and these. Okay, so we'll go through all of these quickly and then we'll understand. Okay, so the first one is, you are supposed to show that the function x squared, or the differential equation x squared plus y squared, okay, then the x minus 3xy dy is equal to 0. So that's what we are supposed to do. Now if you compare this to the general form, you could see that here was what m of xy. Okay, so this is my m of xy, okay, and that is equal to s squared plus y squared, and this is my n of xy, so n of xy is equal to minus 3xy. Okay, so let's check for the homogeneity of m of xy, and that will be m of lambda x lambda y. We just did that. Okay, and that is equal to lambda x squared plus lambda y squared, and this is equal to lambda squared s squared plus lambda squared y squared. Okay, and this is the same as lambda squared into s squared plus y squared, and which is equal to lambda squared. Here is what m of xy, m of xy. So this is homogeneous with degree n equals 2. Okay, so that is it. Now let's go to the n of xy. So we should check for n of lambda x. Okay, n of lambda x lambda y, and that is equal to minus 3 into lambda x then lambda y. Okay, and this will give me minus 3. This is lambda times lambda. Okay, I hope you get that. Lambda squared x y, and this is equal to lambda squared into minus 3. Okay, lambda squared into minus 3xy, and this whole thing will be called lambda squared minus 3xy is what? N of xy. And now the degree n is equal to what? 2. So since the degree of this and this, the both of them, they are both homogeneous and they have the same degree, this differential equation is homogeneous. Okay, this is the first order differential equation, and that is homogeneous. So that is simply how to show that the differential equation is homogeneous. Now let's go to the second one, because we have 5 of them. Okay, and I think I'll give you the last one, an additional question to try. Okay, just try your hands on them. So let's go to the second one. The second question is, you have dy dx being equal to y over x minus y over x squared. Okay, so this, we don't need to solve this, okay, because this is written in the standard form. The first one that we did, it was written in the differential form. I hope you remember that. And now this is written in the standard differential equation form. I mean the first order standard form. Okay, and we said that if the standard form, that is this y prime here, is a function or is dependent on the ratio y over x or x over y, okay, then it is homogeneous. So because of these terms, that this function depends on them, this is homogeneous. So just looking through it, you can say it's homogeneous. Okay, then you start solving it. Okay, we have a method of solving it, and then after going through all these examples, I'll show you the way. Okay, now the third question is dy dx, okay, dx is equal to 4x plus y then x plus y over s squared. This is what we are supposed to also show, that this is what how do I call it, homogeneous. So what we'll do is, you can simply look through this and do, or you can change this to the differential form. Okay, I can actually do this in 2 ways. Trust me, I can do this in 2 ways. So if you want us to do it in 2 ways, that one will be fine. If you also want us to convert it to the differential form, the differential form, then it will also be fine. Okay, so let's cross multiply through by s squared, and we have s squared dy dx. I want to go through it step by step with you. Okay, then plus y into x plus y. Okay, then I multiply through by ds. I have s squared dy equals 4x plus y, x plus y, then dx. So if I send this one to the other side of the equation, I'll have 4x plus y, x plus y, dx minus s squared dy equals 0. So initially, if you send this to the other side, you get 0 equals that, and then you can interchange them. Okay, so you can check the homogeneity of this, which my m of xy is this. Okay, so m of xy, so we can go and write it on the second page. Okay, that our m of xy will be equal to 4x plus y, okay, then into x plus y, and then our n of xy will be equal to minus s squared or something like that. Yes, minus s squared. So we check the homogeneity of m of xy, lambda x lambda y, and this is equal to 4 lambda x plus lambda y into 1 bracket lambda x plus lambda y. Okay, then in the first bracket I can factor lambda out, so I have 4x plus y, and in the second bracket, that one too, I can factor lambda out, and I have x plus y. Okay, and you realize that they are both multiplying, so I can get lambda squared into 4x plus y, x plus y. Okay, and this will be equal to lambda squared, and we know that this is equal to m of xy. And this is homogeneous because we've been able to write this as lambda to the power something times m of xy, which has a degree of what? 2. Okay, and then n of xy is equal to minus s squared. So n of lambda x lambda y is equal to minus, there's no y here, so I just put only the x here, and this will give me minus lambda squared s squared. Okay, and this is equal to lambda squared out minus s squared, but minus s squared is what? N of xy, so I have lambda squared n of xy, which shows that this is homogeneous, and the degree is what? N is equal to 2. So realize that the degree of this is 2, and the degree of the other one is also 2. So it means this differential equation is actually homogeneous. But if you remember, I said that we could have done this straight away without going through the differential form. Okay, so let me raise here and show you how or why I said that. Okay, you just have to bear with me, and then let's go through it step by step, because you need these to go through our next discussion. Okay, so this could have been written as, just divide this s squared by one of the brackets. Okay, so I have x over s squared, so I just divided by that, and it's the same, because this, I could have written this as 4x plus y, then x plus y only over s squared, and this s plus y over s squared is simplified as this, and this will give us 4x plus y into 1 over x, okay, plus, I think, yes, y over x, or y over s squared, or you can say y over x times 1 over x. Okay, and then we can factor that 1 over x out, and you get something like 4x plus y into 1 over x times 1 plus y over x, which in effect we can get it like 4x plus y over x into 1 plus y over x. Okay, this is the same as this. Okay, so now, since this function dy dx, that is a y prime, depends on this, once we're able to simplify a function at the right side, and you see that y prime depends on the ratio y over s, then this is homogeneous. So you could have done this, and then it will be very simple. So since you have this term inside the right side, this is homogeneous. Very simple like that. Okay, I hope you get this. So the fourth one is saying that you should show that y prime equals this, xy prime equals y minus x all cubed plus y. So you can as well go through this and divide through by x, and you have y minus x cubed over x plus y over x. So you could have stopped here and say that once this depends on this function, okay, this is homogeneous. So if you want to still go ahead and simplify, so that when you are working your solution or your way of simplification will become easier, you can go ahead and then simplify. Okay, that is the same as x x out in this numerator. You have y over x minus 1. Okay, minus 1, then all cubed. Okay, when I factor x out here, that is what I have. Then x plus y over x, then I have s cubed out, y over 1 minus, or y over x minus 1 over x, and plus y over x. So obviously this can take one of these x's out, and then we'll have something like, there wouldn't be any denominator here, so I'll have only this, then s squared into that. Okay, and then since this y prime is a function of that, I mean, this time you have two of them, so obviously it's non-homogeneous. Okay, sorry, it's homogeneous. I'm really sorry. Okay, so if you're able to express your y prime as that, then you don't need to show the degree or whatever. Okay, so the fifth one, I want you to go ahead and try that. Y prime, xy prime equals y plus x squared sec of y over x. So you should make sure that before you make your conclusion, y prime should be standing alone. So try this, okay? And then the second one is you should state whether this is homogeneous or not. And after that, what you have to do is tell me the homogeneity. Okay, so this one I want you to comment, give me a comment in the comment section below, okay? And the x equals 0. So this is the second one. So you are supposed to work on these, and then let me know in the comment sections if we're able to do or not, okay? So in our next discussion, what we'll do is, after knowing all these things about homogeneity of first order differential equation, we take an example of a homogeneous first order differential equation and we solve it. I hope you understand, okay? So at the end, you realize that you get back a separable differential equation, okay? Thank you, and like I said, don't forget to subscribe to my channel. See you next time.